Hello, in this video we're going to take another look at work problems and a different type of example. So for this example we're going to look at some pipes and filling up a tank. So this problem reads, at a local soda bottling factory, a pipe leading into a tank can fill it with soda in 2 hours and another can empty the tank in 3 hours. If the valves on both tanks are open, how long will it take to fill the tank? All right, so let's start by taking a look at the information we do have. So let's make a table. So we have a pipe that is filling the tank. So I'm going to call that my fill. And I have a pipe that is it working with this first pipe or not? No, actually we have a different scenario here. One's filling and one's emptying. So I'm going to call this the pipe that drains. If it empties, it also drains. So there are my two scenarios, and in each case I'm going to look at the rate, the time, and the part of task. All right, so in the end, keep in mind that we are still trying to fill the tank. So if I look at my total that I'm after on this problem, I'm looking for one full tank. That's my job that I'm completing. So what rate is it filling? Well, it says that the pipe can be filled with soda in 2 hours. So if only that pipe was open, the tank would be full in 2 hours. So that pipe is working at a rate of 1/2. Again, 1 over the amount of time it takes to complete the task by itself. The rate for the other one is actually it would take 3 hours to empty the tank, so that rate of work for the draining one would be 1/3. Now, if the valves on both are left open, then again the time is the same for both of these pipes that are on these tanks. So my time to fill and my time to drain is exactly the same, so I can use the same variable. Rate times time is equal to part of task. So again, this first one is going to be t/2. Again, I choose to write it as a rational expression. The second one is t/3. Now, this one's a little bit different because these two pipes are not working together. They're actually working against each other. You've got the first one filling the tank, but the second one is draining. So think about what operation might go along with draining. Yep, that's right. We're going to need to subtract the t/3 in this case. And that's going to equal one complete job. So let's see what's going to happen here. Well, a rational equation, I need the lowest common denominator, which is 6. So I am going to multiply both sides by 6/1. And so again, 2 goes into 6 3 times, and then the 3 times the t will give me 3t. But now I have minus. The 3 goes into the 6 twice, and 2 times t is 2t. So I end up with 3t minus 2t is equal to 1 times 6, which is 6. So 3t minus 2t, pretty simple here. T is equal to 6. So it's going to take 6 hours for this tank to fill because we've got two pipes working against each other. But because it takes longer to drain than it does to fill, it will eventually fill up. And so we can determine what that time is. So be careful, not all of your work problems will require that you add. There are some instances where you might also need to subtract.